Okay, so solution video for our inequalities practice problems. Okay, so starting off with number 1, we have v as the variable that we're trying to solve for. Of course, guys, fast forward to a problem that you feel you need help with. Okay, I don't intend on you watching this entire video, but if it's helpful to you, of course, go ahead and do that. Okay, so starting off with number 1, v is being divided by 9. So to undo that, I want to multiply both sides by 9. Okay, thinking what's the opposite of dividing here. So that's going to help that to cancel out. 9 times 7. 9 times 7 gives us negative 63. I drop down my sign, so I have greater than or equal to v. I want to read this backwards. In other words, I want to have a statement where v is first because I want to know where to shade. So on my number line, I'll mark this as negative 63. And I want to know, I know that it's less than, or sorry, right now it's greater than or equal to, so it's going to have a closed circle, but I want to know which direction to shade in. So I need to really have v first. So if negative 63 is bigger than or equal to v, then v must be smaller than or equal to negative 63. So I shade the numbers that are smaller than negative 63, which would be this way. Okay, as a quick little side note, something you may want to write on your paper. If you have less than or greater than, that means you're going to have a closed circle. Sorry, that's not right. Less than or greater than, you're going to have an open circle. And if there is equal to, you are going to have a closed circle. Okay, we've talked about this before, but this is a quick little summary. Okay, so that's number 1. Looking at number 2, I want p by itself, which means I need to get rid of the negative 14. So I add 14 to both sides. Okay, again, thinking of kind of opposites, so undoing. These cancel. I get p, drop down a sign. 2 plus 14 gives me 16. P is greater than or equal to 16, so I pick a place on my number line to be 16. If you want to add some other numbers here, that would just be wonderful, but you don't have to, really. Just a quick sketch is all I'm looking for. So greater than or equal to means we're going to have a closed circle. I'll do this one right on the number line. We can do on the number line or above, like what's here in number 1. Okay, so it could be equal to 16 or p could be greater than 16. So any of these numbers and beyond are going to work. Okay, remember what we're indicating here is the numbers that are going to make this inequality true. So for instance, if I pick 17, 17 minus 14 is 3, and 3 is bigger than or equal to 2. So that's something where this inequality stays true. Okay, looking at number 3. Here we're going to be combining like terms, okay, to start off, because I have a positive 6 and a positive 4. Those I can combine, so I get 10 plus 7n is less than 17. N is what I'm trying to solve for, so I need to get rid of what's around it. The 7 is more attached. The 10 is easier to get rid of. To get rid of that, I need to subtract it from both sides, so those cancel. I'm left with 7n, keep our sign, less than. 17 minus 10 gives me 7. Again, looking to get n by itself, the 7's in the way. Between them is multiplication when they're right up next to each other. So to undo that, I just divide both sides by 7. These just cancel and become 1, so I get n is less than 7 over 7 is also 1. So I get n is less than 1. Pick a place on my number line to be 1. Maybe pick a few other numbers. Okay, I'm going to have an open circle because it's not equal to 1. It's just less than. So I'll do an open circle here. And then it is less than, so the numbers that are smaller than 1. Okay, so my graph looks something like this. Again, it can be on the number line or you can do it above the number line. Okay, for number 4, I have two things that both have to do with R, so I can combine them. They're on the same side. Okay, this is like what divides it into two sides. These are on the same side, so I can combine them. If I have one that's negative, remember if there's no number, it's an invisible 1, so I have -1 and -8. These are going to combine and give me -9. Okay, so I have -9 R's. Drop down this 9, drop down my less than symbol. I want R by itself, so I need to get rid of this -9, so I divide both sides, because right now they're being multiplied. So I divide both sides by -9. These just turn into a 1, right? -9 over -9 is just 1. 9 divided by -9 gives me -1. Bring over the sign. Again, this is just 1. And then R, so I can just write this. If -1 is smaller than R, then R, reading it this way, okay, R must be bigger than -1. Okay, it's going, I hit the big side first as I read this way. Okay, so R is bigger than -1. Okay, graphing this, again, pick a place, call it -1, open circle. Numbers that are bigger would be this way. Okay, number 5, I'm going to start this one. Let's change pen color. I'm going to start this one by distributing. So 6 times -6 gives me -36. 6 times -8n is going to be -48n. Drop down the sign. And -420. I want to solve for n. Right now there's a 48 in the way and a -36. The -36 is less attached, so it's easier to get rid of. So I add 36 to both sides. These are going to cancel out. I get -48n is less than or equal to. Adding these, -420 plus 36. One's negative, one's positive. The negative is going to win because there are 300 and, let's see, 84. So, write that. -384 is what I end up with. Okay, you basically are subtracting these, okay, because some of them cancel out. So I'm left with this. I'm going to divide both sides by -48. Okay, negative divided by a negative. Well, here, let's start over here first. These cancel. I'm left with n. The sign is going to flip because I divided by a negative. Okay, I divided both sides by a negative, so the sign flips from less than or equal to greater than or equal to. Okay, again, I divided by a negative. Okay, 384 divided by 48 is 8. And a negative divided by a negative is a positive, so it stays as n is greater than or equal to 8. Pick a place on your number line, make it an 8. It has the equal to, so it's going to be a solid circle. And greater than, so I shade numbers that are bigger than 8. Okay, looking at number 6. Again, I'm going to be distributing here. Drop down the other parts of the equation. 6 times x gives me 6x. 6 times 8 gives me 48. I see that I have two things that are x's here, so I'm going to combine those. 7x plus 6x, they're on the same side, so I just combine them. Okay, 7 and 6 means I have 13 on that side. Okay, I rewrite the rest of the problem. Now I focus in on the x that I'm solving for. I need to get 13 and the 48 away. 48 is less attached, so I subtract from both sides. 126 minus 48 is going to give me, oh, sorry, 86, 11 minus 4 is 7. So 76, not 76, sorry, 78. So if 78 is less than or equal to 13x, to get x by itself, I divide both sides by 13. These are going to cancel. Okay, 78 divided by 13, I get 6. Drop down my sign. I did not divide by a negative, so I don't need to flip the sign. Okay, so just kind of carry this over, and then 13 over 13 is just 1, so I'm only left with x. Okay, if 6 is smaller than or equal to x, then x must be bigger than or equal to 6. Okay, reading this backwards, I hit the big side first, then the small side. So x is bigger than 6, or equal to. So at 6, I do a closed circle, and I shade in the direction of the numbers that are bigger than 6. Okay, looking at number 7, distribute again. I get this. I have x on both sides. Okay, that's going to be a problem. I need x just on one side. Okay, that's what I was saying in class. It's like the town's not big enough for the both of them. So I'm going to get rid of the smaller one, which means I need to add 40x to both sides. These cancel. I'm left with this. Okay, again, trying to get x by itself. This negative 40 is the less attached thing that's in the way. So I add 40 to both sides. These actually cancel out as well, so I get 0. It's right over here. I get 0 is greater than, just dropping down my sign. 0 is greater than 43x. I divide both sides by 43. It's just 1. So 0 divided by 43 is 0. So I get 0 is greater than x. If that's true, then it must be that x is smaller than 0. Okay, reading it backwards again. Okay, so pick one of these to be 0. Open circle because it's just less than. Shade to the left. Okay. Number 8. This negative here, it's like a negative 1. Okay, there's an invisible 1 in front of the parentheses. I distribute, and I'm going to distribute the negative 4 as well. Negative times a negative gives me a positive, and 1 times x gives me x. Negative 1 times negative 2 gives me positive 2. Moving on to the next distribution, negative 4 times 6x gives me negative 24. X, negative 4 times negative 8 is positive 32. And there's the rest of my equation. Okay, I see things that can be combined. I've got a positive x and a negative 24x all on this side. I'm going to combine those. Positive 1, negative 24 leaves me with negative 23x. Then I've got positive 2, positive 32. Those combine to give me positive 34. Okay, so just kind of condensing what's on this side. I drop down the sign. And then I've got some more x's. I have negative 4x and negative 2x. Okay, they're on this same side, so I combine them. Negative 4 and negative 2 more means I have negative 6x. I notice I have an x on both sides here. And the town's not big enough for the both of them. So the smallest is going to lose, which means I get rid of the negative 23x. So add 23x to both sides. Those cancel out. I get 34 is greater than or equal to, because I just dropped down the sign. Negative 6, positive 23 gives me a positive 17. I divide both sides by 17. 34 divided by 17 is 2. Keep my greater than or equal to because I have not multiplied or divided by a negative, at least to both sides. Okay, this doesn't really count when it's the distributing because it's just to one side. But if you were, say right here, I was left with negative 17, then that would be different if I was dividing by a negative to both sides. Okay, but here I just divided by a positive, so I get 2. Keep the sign the same, is greater than or equal to x. Write it backwards because the x is on a side that we don't like. So I'm going to write this as x is less than or equal to 2. This little double arrow thing just means that it's the same thing as this. It's another way of writing it. Pick a spot to represent 2. It includes equal to, so it's going to be a closed circle. And it's less than or equal to, so I shade the smaller numbers. Okay, so zooming out here, here is the first page. Move on to graphing next. All right, looking at number 9, I need a slope, or m, and a y-intercept, which we call b. Remember, we have the form y equals mx plus b. This is already in the correct form, so I can just look at the corresponding values. M is going to be the number in front of x. So that's going to be negative 4. B is going to be the number after x, so that's going to be a positive 1. When I say negative 4 for the slope, it's probably going to be easier to think of it as a fraction, so I want to say negative 4 over 1. Or I could put the negative down below and say 4 over negative 1. Okay, but we always start with the y-intercept, so I start my first point here. And then I'm going to use the slope as my direction. So the top number, remember, is how far it's going up or down. And the bottom number is to the right or left. Okay, and which way depends on if it's positive or negative. So here our top number is negative, so I'm going to go down 4. So I'll go down 1, 2, 3, 4. And then I go to the right 1 because the run is positive. So that was down 4 over 1 is right here. Okay, so that's my second point. If I want to make a third point, I can go back to the y-intercept, and I can use this slope, which would be going up 4 and to the left 1. So I go up 1, 2, 3, 4, to the left 1. Okay, you can see how these all fall on the same line here. Okay, it's just kind of going backwards. So I'm going to connect these now. The sign is greater than or equal to, so it's going to be a solid line. Okay, a side note you might want to say, if you have less than or greater than, it's dashed. If you have an equal to involved, then it's going to be solid. Your line, okay, when you're graphing in 2D. All right, so here we have greater than or equal to, so it's going to be a solid line. Let me try to make a nice line here. Sort of. Okay, so there's my line. Greater than means I'm going to shade above. So it should look something like this. Okay, looking at number 10, I need to get it into the right form, this y equals mx plus b form. So I need the y to be by itself. To do that, I need to subtract 2x from both sides. I get y is less than or equal to negative 2x minus 5. Again, from this, I need to get the slope and the y-intercept so I can graph. Slope is the number in front of x, so that's negative 2. Y-intercept is the number after x, so that's going to be negative 5. If negative 2 is my slope, I can think of that as negative 2 over 1, or I can think of it as positive 2 over negative 1. Either way, I start with my y-intercept, which is negative 5. Here, going down 2 seems a little inconvenient because I go off the grid, so I'm going to stick with this slope, which tells me to go up 2 and to the left 1. So I go up 1, up 2, to the left 1. I can repeat this so I get more points. 1, 2, to the left 1. Up 1, 2, to the left 1. Okay, so we've got 4 points now. Pretty solid start for a line. My symbol is less than or equal to. I guess I should be looking here. Less than or equal to, so I'm going to use a solid line. Okay, and then I'm going to shade below because it's less than, so it looks like this. Okay, looking at number 11, graphing this system. Graphing 2 lines, they're both already in the right form. They're also both less than, which means they're both going to be dashed lines and shaded below. Okay, so looking at the first line, slope, number in front of x, is going to be negative 2/3. Y-intercept, number after x, positive 3. So I start at positive 3. The slope says to go down 2/3, so I go down 2, to the right 1, 2, 3. Okay, I could do that again if I want a third point. I could also go backwards. Instead of going down and right, I could go up 2 and then to the left 3. So up 2 to the left 1, 2, 3. Okay, just going kind of backwards from the y-intercept. Okay, I'm going to connect these with a dashed line. Oh, sorry. Okay, connect these with a dashed line. And I'm going to just kind of lightly shade below here because it's less than. Okay, in a second color, I'll look at the second equation. So here, m is the number in front of x, which would be positive 4/3. If you want to think about that in a different way for whatever reason, you could also make both of them negative because a negative divided by a negative is a positive. So you can use that as well if you're for some reason going off of the graph. Okay, here our y-intercept is the number after the graph, which would be negative 3. So I start at the y-intercept. I go up 4 and to the right 3. So 1, 2, 3, 4, 1, 2, 3. And I'm at this point. I'm going to connect them again with a dashed line. And I'm going to shade below this line because it is less than. Okay, and I see, of course, that they overlap in this area here. So I want to kind of emphasize that by shading over it again. Okay, looking at number 12, last problem here. Oh, sorry. Okay, number 12. So this one is going backwards. This shaded area that it shows you is where the sections overlap. Okay, so like this section in number 11, that's what it's showing you here in number 12. Okay, so this is, if I can tell, based on the fact that this is where they overlap, it must mean that the solid line was shaded up here and the dashed line was shaded down here. Okay, that's how they end up overlapping in this section. Okay, so I want to find these two equations. This first line here is dashed, so I know it's either going to be less than or greater than. Okay, it's also shaded below, so in fact I know it's going to be less than. So I have y is less than. Then I look at the y-intercept, which is going to be here at negative 1, negative 2, negative 3. So my y-intercept is negative 3. There's always this x here, and then I need the slope to go here. So I count out the slope. So let's say I start at the y-intercept. This is another clear point here, so is this. It looks like I go up 1, up 2, and then to the right 1. Again, I go up 1, up 2, to the right 1. So my slope, it goes up 2, to the right 1. So both are positive. I could simplify this and just say that means my equation is y is less than 2x minus 3. Okay, looking at the second equation, it's a solid line, so I know it's either less than or equals to or greater than or equal to. Okay, but either way, I know there's an equal to part. I see it's shaded above. Okay, so that means it's going to be greater than. Okay, it's the values that are above or more than that line. So it is, in fact, going to be greater than or equal to. The y-intercept happens over here at positive 2. So I know my equation ends with plus 2. I know there's an x in there. I just need to find the slope. Okay, I see these two are clear points, so it goes down 1 and then to the right 2. So down 1 over 2. And that is my final equation for the second line. Okay, so this system that's graphed here is the system of these two inequalities. Okay, sorry for the longer video, but hopefully you were able to fast forward to wherever you were having difficulties, and you can use this as a study guide to help you for Friday's test.